theoretically we are live.
Whoa.
So there should be a happy new layout that everyone can enjoy now.
You need to send me this layout, assuming I can't see it, so I'll need to take
Well,
your word for it.
you can run YouTube and just mute it and take a look at the layout.
I'm seeing.
It's
Weird.
probably still getting past the buffering.
Mm-hmm.
Wait, I see people saying you're live. There's
Yeah,
Pamela's
people are
voice.
saying that we're live. All right, let me see. I just want to see. Let me turn off the. Oh, that's super spiffy. You got the WSH Crew logo there. You've got the Astronomy Cast logo. The Slack is over top of the WSH Crew, but
No, so that was done on purpose. I looked at how news companies do their lower thirds, and I just mimicked that.
Okay.
So, yeah.
I dig it. You should definitely send me these parts for this.
Okay.
This is great. So check it out. I'm not in control. Pamela is in control.
It's true.
And yeah, and this was sort of one of our objectives in the last couple of weeks, was to just sort of, Pamela's been the queen of live streaming over on Twitch, and we thought we'd put that power to use over on Astronomy Cast and have her take over. So now we're more redundant, because now if Pamela's traveling, then I can host. If I'm traveling, then Pamela can host. Of course, we know Pamela's going to be the one traveling, so I'm going to be the one hosting. But the point here is, it's true, I do. And in fact, I'm going to be traveling in early February. So, and who knows whether I'll want to try and give you some kind of live Astronomy Cast from Iceland with Paul Sutter.
That would be awesome.
But one thing you can't do is say hi to everybody.
It's true.
So I'm going to say hi to Arnold Post, Astro B, Ben Kalo, Bill Druin, Bill Sugden, Carolyn B, Chris Adams, Colin Jones, Gordon Dewis, Guido Bibra, Harry M, John Seffield, Johnny Zed, Quad Libet, Larry Beckham, Linda Sadek, Michael Jobin, Nancy Graziano, Noel Ruppenthal, Paranor001, Paul Gracie, Paul O'Neill, Peter Quinn, Rinstro, Rachel Fry, Richard, Rick Schwartz, Ryan Schmitz, S. Wahlberg, Scott C. It's a lot of people today. Sergio Botero, Sylvan Westby, Susan Hunter, Susie Murph, Tom Ben Scotter, Wayne Johnson, and Zappan. Hey, everybody. Just to be clear, the reason that you won't be naming the participants is because you mess up people's names, I believe, more than I do.
I do. It's true. It's totally true.
Yeah. And that's all, really. I mean, I mangle things with my Canadian accent, but and people give me a hard time. People give me a hard time when I pronounce things wrong. It's pronounced Euler, not Euler. And then I'm like, hey, Canadian, like oot, a boot, pasta.
I screw these things up too.
But yeah, so this is great, and I think the goal as well with the Weekly Space Hangout is to get the crew, the other co-hosts, to be able to do the same thing. So.
And the nice thing about using OBS is I can just export these layouts and get them to you. And we're not currently screen sharing, but I also have a nice friendly layout for if we are streaming a video. And I can easily create anything else we may need. Little do people know, but I'm also a graphical artist.
Graphical artist, website designer, computer programmer, also astronomer.
Yes.
And also communicator. So you really are the whole pack, and a lovely voice.
Thank you.
So let's, for people wondering what it is, it's very strange. I don't know what to do with my, someone says I don't know what to do with my hands. So I'm sort of, I've got a T-ring here, and I'm just sort of spinning the adapter back and forth. But it's very loud, so it's not a good idea. Maybe I'll just like play with my coffee cup. I don't know what to do. Anyway, let's get on with this episode of Astronomy Cast. Whenever you're ready, I will press record. Also, man, there's so much news today. I can't. It is news Christmas.
You talk about that. I forgot to open Audacity.
Oh, okay. Well, that'll only take you a second. But here's what's coming in the news pipes. They just put the Parker Solar Probe in NASA's gigantic vacuum freezer, just like they brought out the James Webb. So now it's Parker Solar Probe. You mentioned this to me. I don't think it was in the live show, but Mars is the perfect place to grow hops, turns out. Which you mentioned, they tried potatoes. I think it turns out hops are even the best. Astronomers have narrowed down the search for axions, so they've sort of set some of the limits, which is really cool. This is one of the ideas for what dark matter could be, but it sort of completely breaks supersymmetry and all this other classical models of physics. Astronomers to figure out how quickly the sun is losing mass by studying the orbit of Mercury. So they've actually been watching the way Mercury's orbit has been changing a tiny little bit. Chinese scientists have achieved practical quantum satellite communications over 1,200 kilometers. So they've literally now got practical way of using quantum encryption to communicate with satellites. It's amazing. Someone has developing a new kind of propulsion system that doesn't use propellant. It converts electricity into thrust and vice versa. So if you've got a spacecraft that has electricity, it can use, and it's orbiting Earth, for example, it can use that electricity to change its altitude. And so it might be a way for things to be able to maintain their height as opposed to needing propellant, which is really neat. People are suggesting we search for space viruses. The solar eclipse caused a bow wave in the Earth's atmosphere when it passed by. Yeah, it was really cool. For some mysterious reason, NASA has pulled Jeanette Epps from the next space station mission, and we don't know why. There was one other one too. Oh man, it's what's the other one today? Oh yeah, the afterglow from the kilonova is brightening.
Really?
Yeah.
The one in August?
The one in August is brightening.
That's normally not a thing.
That is normally not a thing. Correct. Oh, and NASA is building a tiny fission reactor for future Mars missions. So it's really cool. And they're doing this with the Department of
Energy.
Of energy, yeah. And they're developing this tiny little fission reactor that people can carry and set up on the surface of Mars and do that. So anyway, needless to say, we're going to be busy here at Universe today. So much news. It's crazy. Dang. Anyway, yeah. But let's get on with this thing we like to call Astronomy Cast. Let me know when you're ready, and I will.
Okay.
And I will begin. I
think I'm ready. The one thing I don't like about this particular layout is whenever I look at my screen, it looks like I totally disdain you. I have a screen over here. I have a screen over here. I have a camera in between the two screens. I don't mean to disdain you. It's just the layout of the monitors.
I've been doing the same thing to you for the entire time that I've been hosting, in that I have two cameras. So one camera, what you're doing too, right? So one camera is you're using for the broadcast, and the other camera you're using for our conversation. But in my case, I've done the small nicety of pointing that second camera roughly close, but nobody gets to see what's on the screen and all that, right?
It's true.
So anyway, enough blah blah blah. Let's get on with this.
I'm ready to click episode. Record.
I'm ready as well.
I am clicking record.
I already did it.
Hello, Chad.
Hey, Chad.
Go eat more pastries. Oh, I'm using the wrong mic. Dang it. I don't even know how that happened.
I'll stop my recording.
Why on earth?
What do you mean? Computers are stupid. How do you mean how? Like, how is it ever? I find it amazing any day that we ever get computers to do anything.
I installed a whole bunch of happy little updates, and they ate all my settings, so they were unhappy updates. Okay, I pressed record again. Hello, Chad. Go eat more proggish, fabulous pastry thingies.
Is that what he's powered by now?
He's not, and I don't know how he's not. Like,
how do you know that he's not?
Because we've had many discussions about this. Because he's in one of my favorite cities, and it contains my favorite pastry of all pastries, and he had his first one on New Year's, and I mocked him with love. That's
adorable. All right, here we go. Astronomy Cast, episode 475, Fast Radio Bursts. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today. With me is Dr. Pamela Gay, the Director of Technology and Citizen Science at the Astronomical Society of the Pacific, and the Director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
Doing great. I've got a couple of things that I have to sort of shamelessly self-promote, and that is I was a guest on the Decipher Sci-Fi podcast last week, and we talked about Black Mirror. So I got a chance to just go off the rails on 3 episodes of Black Mirror and tell people what I thought for the first the USS Callister, which is probably my favorite Black Mirror episode ever, and then 2 others, Archangel and Crocodile. So one, as a helicopter parent, hit me right between the eyes.
Yeah, that one was terrifying.
Yeah, and then the other one was like, yeah, it's all right.
I don't think I got to
but
that one yet.
It had some stuff that we thought was a pretty clever idea. Anyway, so if you want to hear me not talk about space and astronomy and instead nerd out about sci-fi and Black Mirror, you should totally check out Decipher Sci-Fi. And I'm search. I'm sure you can find it where all good podcasts are streamed.
Sounds good. Now, you said you had 2 things, and that was one.
No. Well, I'm a little jumpy today, and it's only because there's an enormous amount of news is coming out of the space and astronomy sphere. So many amazing stories, all just broke today, and I don't even know where to start. So needless to say, there's going to be check the news. It's really interesting. That's my second thing.
Don't look at the political news, because we're aiming towards a government shutdown, which has me dead inside.
No. Space news. Just the space news.
Okay, so yes, all good things. Go to Universe Today, read about them.
Yeah. All right, so you know what's fun? Mysteries. Here's one: fast radio bursts. Astronomers have been detecting mysterious one-time signals from across the sky. What's causing them? Nobody knows for sure, but the search is on to get to the bottom of them. I love this mystery of fast radio bursts. I did a video on them about 6 months ago, so I feel like I kind of know what's going on. But what are they, or at least what has been detected so far?
So I can tell you the observables. I can't tell you what they are.
Right. Well, but we'll speculate.
We can do that.
Yeah.
So what they are is, for a handful of milliseconds, astronomers will utterly randomly detect a extraordinarily powerful burst of radio signal across a variety of different wavelengths. And this is very reminiscent to how we first started discovering gamma ray bursts, where there was this moment of huge energy followed by silence before you could actually get a telescope pointed at where the gamma rays were coming from. And just like with gamma rays, they are, as near as we can tell, randomly distributed across the sky. Now, the reason I say as much as we can tell is because you have to be pointed in the direction that they're emitted from in order to detect them. Gamma ray bursts are happy to be detected even if they're like beside directionally your telescope. They'll just blast through the telescope to be detected. Radio waves are a little more finicky. You have to actually be looking in the direction of the light. But as near as we can tell, they come from all directions.
And how were they detected in the first place? How did they turn up the first fast radio burst and realize that this was a thing?
Well, the first one was actually in reviewing archival data. So back in 2015, some folks were going through Green Bank Telescope archival data from 2011.
Sorry, I gotta call you on this. They were actually discovered earlier than that. They were back in 2007.
They were found. You're right.
People were looking through even older archival data. Yeah, from 2001 from the Parkes radio dish in Australia.
Why?
Look at the Lorimer burst.
Okay. This is how the sausage is made, people. This is how the sausage is made. You're right. Of course you're right. Hold on. Let me put this into my head. We're sorry, Chad. You're going to have to edit this because I didn't read all the documents in the world. I love how, okay, I now have sarcasm to go with this discovery. Okay, I'm ready to go. You want to re-ask your question to give Chad a clean edit?
Sure. So, I mean, we've got a sort of a bit of a sense of what they are, but how did just the understanding that these things were happening at all, when did this mystery begin to unfold?
It turns out it was actually a student going through archival data in Australia. The person who it is named after, of course, is the advisor and not the student.
Right.
As so
familiar.
often happens. Yeah, I mean, it is the way of things. As long as he doesn't get a Nobel Prize, I'm okay with this. Not really, but I'll pretend.
Or they get to share it. They get to share it.
Yeah.
That's how it works.
So it's referred to as the Lorimer burst after Duncan Lorimer, who assigned his student David Narkvek. Sorry if you're out there, David. I don't know how to actually say your last name. So David was going through archival data that was taken by the Parkes radio dish in Australia. And there was this weird burst that seems to have gone off on July 24th, 2001. It was 5 milliseconds in duration and vaguely in the direction of the Small Magellanic Cloud. It was a few fingers off the edge. And they didn't know what it was. They didn't know exactly where it was other than in that direction. It seemed, given the brightness, that it probably wasn't local. Because if it had, we would have seen lots of other things associated in that direction that we just didn't see. So it was sort of like, there's something going on here. Let's look more. And this is where people started looking more.
Right. And the problem with this burst and all of them, as you said, right, 5 milliseconds. So a fraction of a second, and then it's gone forever. And the thing was, in the beginning, they didn't seem to repeat.
Right.
Like pulsars, like other things out there. And so how do you go looking for something that comes and goes in 5 milliseconds?
Yeah. And I think we'll get to that because
yes.
Folks have started trying to get to the bottom of that. So the thing was, this first one was found by a student in our archival data in 2007. And the next time someone actually flagged one wasn't until 2012 when the Arecibo radio telescope, so these are like one at a time telescopes all over the world, confirmed that there appeared to be an extragalactic origin to one vaguely in the direction of Eurasia. So now we have one that is being detected in the northern hemisphere. This was done by Paul Schultz of McGill University. So now we have a Canadian.
Yep. This story is going to come back to Canada pretty heavily.
Yeah,
so
it's
stay
true.
tuned.
It's true. Canada does amazing science. You guys publish
But we
more.
have the perfect instrument here for both doing some sweet snowboard grinding and also detecting fast radio bursts. So we'll get to that.
One of those is more useful than the other for this particular episode.
Yeah.
So here we have another one of these fast bursts, and they started going through more and more of the archival data. In 2015, going through this data, it got to the point that Paul had found 10 of these in non-periodically repeating. So it's just like, here's one, here's one, here's one. And they all seem to have plasma dispersion associated with them. So this means that they were seen across a wide variety of different wavelengths in a very characteristic fashion. And this is where people start making up stuff to try and figure out what the heck this might be. And among the guesses is that maybe it's some sort of a young rotating neutron star where there's plasma interactions, or it's a highly magnetized situation. Again, neutron star. Here we have our magnetars to blame.
Right. So can we just stop on that for 1 second? I just want to sort of understand that mechanism. Like with the traditional pulsar, which is essentially a neutron star. It's a rapidly rotating star. It is firing out blasts of radio waves on a very regular basis. So what is different from the radio waves put out by a pulsar neutron star, or in this case, how does it different from a fast radio burst?
So when we have a pulsar, it's not that the pulsar is giving things off in bursts, it's that the pulsar is rotating. And just like a lighthouse on a coast, when you have a rotating light, it appears to an observer who's stationary to be blinking on and off as the light rotates into and out of view. With pulsars, you have the magnetic field of the pulsar out of alignment with the rotational axis of the pulsar. And the Earth has this too, the idea of a magnetic field not being aligned with the rotation of an object. There's nothing weird about that. But with the magnetic field out of alignment, every time that pole of the magnetic field is pointed towards us, we get a burst because we can see down the mouth of the magnetic field. And that's the pulse. Now,
right.
We have a continuous beam that is nothing more than we're seeing the field and its interactions. With this, it's as though periodically something interacts with that magnetic field.
Right.
And
so you can imagine some kind of like plasma environment around the neutron star, and then something is getting eaten or something is interacting, and it's just this completely separate. And so we might not be able to see the regular beams from the thing, but every now and then something chirps and then it's gone.
And it could be, these things aren't getting labeled as pulsars yet. We don't have enough data to label them.
And they don't match pulsars.
And they don't match pulsars at all. So this could be, instead of a pulsar-like mechanism, it could be anything from magnetic fields rearranging themselves to eating asteroids. This is a thing they can do. To perhaps there's a nearby star that they keep periodically stripping a little bit of material off of, and we get a nice friendly radio burp. We don't know. We're at the cool speculation phase of this. So
right.
We have very limited data.
My favorite phase.
But at least we have observables. So
yes,
I can constrain your parameter space.
Okay. So how do we know, right now, all we know really is that they seem to happen randomly. Do we know if they're happening inside the galaxy, outside the galaxy?
They appear to be extragalactic. So there's two reasons to say this. The first is the distribution. If something is galactic, you generally expect it to be primarily in the disk. These are, as near as we can tell, as I said, all over the sky. The other thing is there's some really cool observations that have recently come out with press releases from at least half a dozen universities, I think, of observation of... Sorry, I'm on allergy meds. Chad, please forgive me. There are a series of observations with what feels like half a dozen press releases or more associated of a fast radio burst that they are naming 121102, because astronomers name things in uninteresting ways. And these all seem to be bursts from roughly the same object. So we're starting...
By the way, that number is the date.
I know it's the date. We still name things in uninteresting ways.
Yeah. So, FRB 140514, for example, was April 14th, 2014. But anyway, please continue. Sorry. Just in case people are wondering, when they're trying to decipher those cryptic and quixotic FRB names, it's the date.
It's true. So there was a long series of observations of this particular source, and it appears to have gone off 15 different times while being observed. And
Repeat. It's a repeater.
It's
like
a
something
repeater.
That's repeating. Yeah, which is like that's a gift.
And so here we are. We have one that is going off on a regular basis. We have 400 terabytes of data on this sucker, and it's across all sorts of different wavelengths. So it spans from 4 gigahertz to 8 gigahertz, and looking at it, it gives us a sense of this is an active object. It gives us data. We still don't know what the heck it is. But
Right.
One of the things that I love is the justification for how they got this data. Do you know the justification for how they got this data
What?
in part? So one of the theories on the origins of these things is that it's extraterrestrial communications.
Sorry. If you're, yes, I know some of these, and and there's an even cooler thing. But go ahead and talk about your part, and then I'll talk about an even cooler part.
So part of the drive to do this, and part of the name of the project, is they were actually looking to see if they could figure out if this was extraterrestrial origins. So this is a project called Breakthrough Listen, and I just love the fact that they're like, okay, we're going to rule this out, and we're going to get amazing data that can be used for science, for the hunt for life, for all these different things. The idea behind this project is they looked and looked and looked and looked at a little tiny dwarf galaxy about 3 billion light years away, trying to understand what might be in that dwarf galaxy.
Yeah, Breakthrough Listen is involved in SETI in general. They're providing telescope time, providing, helping fund various scientists to search for signals from extraterrestrial intelligence, and this is one of them. And so the idea is that maybe aliens are using these FRBs to communicate in some way.
Yes. So basically the way to think of it is we have periodically sent out bursts of laser light in order to nominally communicate with aliens out there. And the thought is, what if a particularly advanced civilization, instead of sending out bursts of laser light, instead sent out bursts of fast radio signals? Maybe it's a thing. It could be a thing. It's as good a theory as any. It just requires a lot more evidence than many of the other theories before someone will believe it. But it's worth looking into, especially when the data needed to look into that theory is good to also prove and disprove a whole lot of other theories. So in this case, one of the things they were able to disprove is that fast radio bursts come from catastrophic events. Because once, in general, unless you're Ada Carina, once you explode something once, you're not going to explode it again. And where they're seeing multiple bursts that appear to be coming from the same place on the sky, that seems to rule out the idea of a catastrophic origin to these things.
One of the things that I thought was really neat was I think it's the Parkes Observatory or the Australia. Yeah, so in Australia anyway, one of the observatories that they're using, one of the interesting things about it is that it is farsighted. So this instrument can't detect anything that is within 10,000 kilometers of the Earth.
Why?
And so I don't know, the way it's tuned. It's
okay.
I don't know. But the thing that's really fascinating about it is that confirmed, it was able to detect these fast radio bursts. And what that did was confirmed without a doubt that they're extraterrestrial in origin. I mean, they could be coming from the moon somehow, but they're definitely not coming from within 10,000 kilometers of the Earth. And I thought that was really fascinating.
Wait, 10,000 kilometers is, so that's nearby. That would be something moving very fast across the sky. So that means they have a very small field of view. Okay, I now track how that could be possible.
Yeah, so it's just, it can't detect anything that's within that range. And so they were able to then essentially rule out satellites, secret military satellites, pieces of space junk, things like that, which I thought was great.
So we're up to the point where We know some of these things replicate themselves. Well, they don't replicate, they repeat themselves. We know they're scattered all across the sky. We know they're probably not cataclysmic events. And that's all we really know. And what's fascinating is how few of the possibilities of what they are we've been able to rule out. Because if it's a matter of eating asteroids, well, that can repeat if you have a really dense field of debris that your happy dead star is moving through. You can have repeating of stripping material off of your nearby neighbor star. And we know from recurrent nova that some of these events repeat on a very regular basis, some repeat on a completely random basis, and some don't repeat within a human lifetime. So we still don't know a lot.
Yeah.
And that's awesome. This is why we do science. And what's cool is looking over this, it keeps being students and young early career people that are making all of the breakthroughs because they're the ones asked to do the boring work. And these quirks just keep showing up in the archives.
And one of the things that, we've talked about this a bit in the past, that attempting to scan the sky for radio waves is very different from attempting to scan the sky for visible light.
Yeah.
We've got some pretty amazing telescopes coming shortly. They're going to be these all sky surveys that are scanning the sky every night, that are gathering enormous amounts of data. And you could imagine even like some kind of telescope that's watching the sky for some bright flash, and there's like the various gamma ray observatories out there that are scanning the entire sky waiting for a burst. But the problem is that you can't scan the entire sky very easily in radio missions. You have to sort of listen spot after spot after spot, right?
Yeah, and you have to trade off resolution for coverage, because when you're doing radio, you're essentially observing one pixel at a time. And so you scan across your object. Now, if you have a giant pixel, you can say whether or not there's an FRB over a long period of time in this one little tiny place. Or you can just keep scanning that one place over and over and over and get a much more focused location, but decrease the probability you're actually going to see something because you're scanning across it.
Yeah, because it's going to like miss that 5 millisecond moment when it went off and then never came back.
Yeah.
I've heard estimates that there could be 10,000 of these a day.
Yes, that's some of the calculations.
And it's just that, this shows you the level of coverage. Say there's a few hundred have been detected, if that, to date. Dozens have been detected to date. It's amazing to think that there could be 10,000. And that just shows you how little of the sky we're watching in radio waves on a regular basis. And that shows you the challenge of things like SETI to search for signals from extraterrestrial intelligence. You've got to point in one place, tune to the right frequency, listen, point to a different place, tune the frequency. So let's talk about some upcoming instruments they're going to try and take this step further. And as I was mentioning, the sweet half pipe is there's an instrument that's going to be built, or has been built, called Chime. Yeah, and it is here in British Columbia. It's in the Kootenays. I really want to go and check out the facility at some point. And it looks like a bunch of skateboard half pipes.
It really does.
It does, yeah. Bolted together. I think it's like 3 maybe or 4. And it is like the perfect machine for finding FRBs.
And go ahead.
Oh, it stands for the Canadian Hydrogen Intensity Mapping Experiment. And so, it has other jobs, right? But go ahead.
So I was going to say, this is a big Canadian collaboration between University of British Columbia, McGill, University of Toronto, and your National Radio Council and the Dominion Radio Astronomy Observatory. It had its first light in September. It's up and operating. And when they were building it, The goal was to be studying the expansion of the universe, trying to understand dark energy, trying to constrain our lambda cold dark matter models. But it turns out the kind of data that they're getting in order to understand all of these other different things has the potential to turn up basically thousands and thousands of these fast radio bursts if they are as common as we believe they are. What's interesting is they also hope to use it to detect the kinds of things that generate gravitational waves. These are the neutron-neutron star collisions like were observed back in August. So here we have a new telescope that is essentially designed to do only the most cutting edge of science involving weird stuff we know almost nothing about and how our universe is expanding.
Yeah, and specifically, it's tuned to the 21 centimeter radio wave, which is what is what's emitted by neutral hydrogen.
And it's tuned to observe them redshifted so that it's observing the most distant clouds. So they've adjusted the wavelength so that it's that redshifted 21 centimeter that they're observing.
And this is one of this mysterious times of the universe, wondering how those first clouds of hydrogen came together to form the first stars. Did they collapse directly into black holes? Did they turn into stars and then the stars merged into black holes? It's a really mysterious time. And I mean, James Webb is going to help us get to the bottom of it. But you know, it's nice to know that we don't have to necessarily wait for a super duper space telescope to start getting some answers.
And what's kind of amazing to me is this particular telescope. It's not exactly steerable, you might say, and it's only going to map 3% of the sky. But 3% of the sky is all we need when you consider the increasing volume that can be seen at larger and larger distances. And so it's going to do a fairly complete sample of this cone through the volume of observable universe. And that's going to help us answer all of these different questions. And this is very much the same strategy where Kepler is looking at a single field and getting us all the information on planets in this one cone in the sky. It's the starting point for the Sloan Digital Sky Survey that looked at initially one place on the sky and measured that cone. And over time, all these cones start to give us a statistically useful amount of information where we take what we saw in the cone and then multiply it out over the rest of the sky to figure out what should be observed everywhere else.
And I mean, we've mentioned this a bit before when we talk about some of the other instruments and surveys and stuff that are coming out, but I think really feel like we're entering this next revolution of time-based astronomy, where we're not just looking at things in ever greater resolution and detail. We are shifting towards seeing what the sky is doing when we're not looking. And you know, the Large Synoptic Survey Telescope is going to be the best example of this. But you can imagine this future when we are watching a goodly portion of the entire sky across many different wavelengths and just getting a sense of how active and unusual things are. Before we wrap up the show, I got to throw in the craziest speculation for what this could be.
Crazier than aliens?
Well, it's aliens, but it's crazier than aliens. It's crazy aliens. Aliens. So one of the ideas is that I think the astrophysicist Avi Loeb did the calculation, but I'm not entirely sure. But he sort of has his hands in everything. So one of the ideas is that it is a gigantic spaceship propulsion system. And so we've talked about this in the past, that seems to be one of the most effective ways to send spacecraft from world to world is to use a laser, and you zap your spacecraft with the laser, and then that propels the spaceship to, you know, head off to its other destination. This is what the breakthrough starshot is going to be. And so they did the calculations and found that if you could release some significant portion of the amount of energy that, for example, the Earth receives every year, in this gigantic laser pulse, you could emit at this huge redshifted distance that amount, that kind of radiation for that frequency for that length of time, and that it would be enough to send a fairly significant spaceship on a fast journey to another star, which I love.
Yeah. And what's
Of course,
cool,
it's not that, but still,
yeah,
it's cool.
Yeah. And we're dealing with redshifted light. So it's awesome.
Yeah. So we're seeing something that is billions of light years away, but it has been redshifted from the whatever laser beam they're using to the radio spectrum.
Now, does that explain the polarization and everything that's being seen?
Well, that's the thing, right? Is that some of these things are now seeing the kind of polarization that perfectly matches, what you would see in a highly magnetic environment, as you mentioned. So it really feels like now what you mentioned, right? That a neutron star is gobbling up an asteroid. Yeah. It's creating this release of energy that's being funneled through the highly magnetic environment, and you're seeing this zap.
Yeah.
But again, more data necessary.
It's true, and we're working to get it with CHIME, with collaborations of so many of the different radio telescopes across the world, Green Bank, Arecibo, the folks down in Australia with all their different radio telescopes. This is an amazing new thing to chase down.
Yeah.
And annoying because it's so brief.
And I feel like we're going to be able to come back to you. This is one of them that I feel like we can come back to you in 5 years and say, we pretty much know what FRBs now. And when we do, we'll give you that follow-up episode. But here's a crazy mystery. We don't know what it is.
But we have observables. Have fun. Enjoy the mystery. Thanks, Pamela. Thank you, Fraser. And now we save.
But for how long?
This is 474, you said?
75.
75.
Yeah. I've really got to clean up my desktop now. I have so many projects saved, so many Audacity projects saved from this, the Weekly Space Hangout, other people's stuff. Yeah, it's crazy.
I totally get that.
Yeah, my desktop is just filling up with my audio files. All right, I'll save that.
Okay. Error saving project.
No!
Let's try this again. It's actually export audio
we save
to
it.
wave.
I like to save it first, then export it.
Well, I tried that and it failed, so I'm going to do a...
Yeah. While we get here, Abraham Cottrell asked, how do we, I missed how they knew it's redshifted. So the point is that it's the other way around, which is that you calculate you assume that it's redshifted. So you say, like, if it was redshifted, then this is what the original amount of radiation could be. You know, for example, like when they look at the cosmic microwave background radiation, they're assuming that it used to be ultraviolet radiation that has been, you know, from the initial moment that the sky went transparent in that release, and then it got redshifted by the distance. And so that's how you calculate, knowing the wavelength of what it originally started with. That's how you calculate the size and age of the universe.
And one of the things that we often do is create filters that will specifically detect the peak brightness line. So like Lyman alpha emission in galaxies of specific redshifts. So say that you're trying to measure emission line galaxies at a redshift of 4. You might make a broadband filter that is specific to only capturing the wavelengths of light associated with Lyman alpha that has been redshifted for galaxies between a redshift of 4 and 5 or something.
All right, so let's take on some questions, and then, as always, you can ask us anything you like about anything, and we will speak to it. So let me give you some feedback first before we begin this episode. My suspicion is trying to run the live stream is a pretty additional cognitive load on your
Yes.
brain,
Yes.
in addition to you attempting to dig into your astrophysics, radio astronomy, and observing knowledge. Whoops.
Well, it's not that it's a cognitive load, it's that it's a cognitive distraction, because I didn't need to do anything with the production. I just kept seeing stuff moving.
Yes, no, exactly. It's distracting. So my recommendation, I think, for the future is this is great if we have to.
Yes.
But let's try to let you just, because I'm really enjoying not having to do anything else. I'm just like sitting here getting a chance to just talk. And so I definitely appreciate the fact that, for you need no distractions. You need to be able to just focus on bringing the massive brain. So
but I want to know, what do people think of the new layout? Is there anything you'd like to see changed? Is there anything else you'd like us to add?
Yeah. But this is great. I mean, if we need to, we can do it. But in general, let's protect your let's protect your attention and let you just focus on doing the show side of it. Gordon is asking, are they just outside the galaxy, or are they found between galaxies? All we know for sure is that they're outside the Earth.
We're pretty sure that they're at cosmological distances, because the one that's been seen to repeat over and over and over seems to be tied with a dwarf galaxy that's about 3 billion light years away.
Yeah. People like the layout. So you're going to have to send it to me and we'll get set up so that I can use that layout. And then it's different from the Weekly Space Hangout one, or I can use both of them. So that sounds great. Ben Kalo asks, do gravity waves redshift? Yes.
Are you sure?
Yeah, the universe is expanding.
Yeah,
they're moving away from us.
That's true, they would. But it's a... So there's two different types of redshift that we have to include when we're calculating redshift. There's the redshift due to an object moving away from you, and there's the redshift created by the expansion of the universe. The redshift that we're going to be dealing with here is the expansion one, not the movement one.
Right. But both are probably at play. Right? If a neutron star collision is coming towards you,
yeah, that's true.
You're gonna, right?
Yeah.
Paul Gracie just noted not fully collimated, and that's the word I was searching for, which is, when you get a telescope that is out of focus at a certain point, it's collimation. And so this observatory in Australia is collimated for extra Earth signals I think on purpose. And so that's why that was the term, as the collimation of the observatory.
I still need to read more about it.
I will send you. We did an article and I sort of incorporated this into a video. So
okay.
Ren and C Brazil, any news about the Falcon Heavy? The static fire was delayed for today and it's going to be happening tomorrow, probably. But, come on. Like, we've been watching the static fires get delayed for weeks now on a mission that's been delayed for years now. So we can be patient. This is all right. What else have we got?
It's still sad.
Gordon says it looks like you have cheat sheets on your ceiling. Is that the way this wherever your camera is? Perhaps you look up and you're...
Oh, so it turns out my brain stores information up here somewhere.
Yeah.
So whenever I'm thinking, I tend to either look down or look up. Those are the two places information are stored.
Yes, that's awesome. Arjun wants to know, how would primordial black holes work? Would they just be knocked in the original universe, or would they be overdensities that immediately collapsed into black holes early?
So they would have been essentially knots that formed prior to release of the cosmic microwave background.
Yeah.
So we know that there were acoustic waves moving through the early universe when it was essentially a really thick plasma, and it would have been possible for black holes to form in this plasma.
There is no there's no way in our current universe that you could get a microscopic black hole. They would
Right.
have to have been formed by
Primordially.
overdensities. Yeah, in the early, hence the
But
name.
any microscopic black holes that formed primordially should have evaporated by now. So, where we start wondering about primordial black holes is when we look at these weird mass ones that are getting turned up in gravitational wave detections. So there's been a few times that when we look at the masses of what should have been merging in, I think we've had 7 detections now, the masses just don't match stellar mass black holes, and they don't match supermassive black holes. And so the thinking is maybe these are mid-range primordial black holes.
Yeah. And this is thought to be one of the answers for what dark matter is, but very few people think that's the case. Paranor says, I do the same thing with my eyes when I'm thinking, except that's where I got the Slack chat. So I have 4 screens in front of me, and so up there is where I put the Slack chat. So I don't know whether do I look even further? I don't know.
Yeah, I have a bulletin board up there, so it turns out I'm actually looking at like Buffy, Princess Leia, coffee, a Banksy print, a dragon staring at a bunny rabbit. I'll tweet a picture of my bulletin board.
People are talking about all the various launches that are going to be happening today as well. So there's going to be a ULA rocket. So good luck with that. I think it's an Atlas. And then also there's a New Zealand launch. That's I think they're doing sounding rockets. Des Woolley says we should advertise Image Detective over on CosmoQuest. We should always do that. Advertise Image Detective.
So we have a cool newish project over on CosmoQuest called Image Detective, where we need your help to label the 1.5 million unlabeled astronaut photos. So it would be awesome if people could use these images for research, for illustrating books, for school projects. And right now it's just a database sorted by date. And that's all we know is when they were taken and where the space shuttle was, or rather the space station was when they were taken. And that's not enough for them to be useful. So we need you to go through and mark, this is an image of outer space. This is an image of the planet Earth. Oh, this is an image of the planet Earth that happens to be pointed at farmers' fields in Mongolia. Or at least just farmers' fields. Sometimes we can't figure out where the farmers' fields are. It's the most amazing game of where in the world is Waldo, trying to figure out what these photos are. So if you have some spare time, go over to Image Detective and help us label photos.
This is awesome. MN asks, do you have any comment on the Zuma mission success or failure?
So I have heard that there were observations of a fireball coming in over, I think it was Africa. I haven't heard follow-up information from the amateur astronomers seeing something with a repeating orbit at the initially detected orbit. So I think there was a lot of pouting, sad people who spent money on something that came back down.
Yeah. Now, it's possible that it worked exactly as expected and did precisely what it was supposed to do, but it's also possible that it failed and that it's so secret that nobody is willing to talk about it.
Yes.
And that it seems weird to have a satellite, and the plan for the satellite launched on an orbital rocket is for it to crash back into the atmosphere. SpaceX has apparently pulled the launch badge from their store, and I've heard that now some like politicians are sort of rattling around trying to find out what's going on and potentially using this as a way to put some shade on SpaceX. SpaceX says that the rocket did precisely what it was supposed to. Everything was fine, and the sort of very top, the part that was attached to the actual satellite, was built by the supplier, was not supplied by SpaceX. So that's it. There's nothing else. There's no other information, and so everyone else is just going to be
I just
going
love
in circles.
SpaceX is like, our stuff worked. That's all we're saying is our stuff worked.
We put that thing into space. We said goodbye to it. We landed the booster. Did you notice how we landed that booster? Because that was awesome. And then that's it.
Yes, not our problem. It is kind of the ultimate, not my monkeys, not my circus.
So who knows?
Yes.
Does anyone have any information about what happened with NASA pulling the astronaut from the ISS mission?
I haven't seen anything other than they're saying she'll fly 2019 at the earliest.
Yeah. That she's coming back to mission control. She is being put on astronaut desk duty. So that is very unprecedented. We have not seen this happen before.
Well, during the Apollo missions, they pulled one of the astronauts because he got sick.
Yeah, medical reasons. So, but they would have said, right? They have said, like, there's some kind of medical issue, or
so we don't know, and so I please do not take this and turn it into a conspiracy theory. People who are out there, do not make a conspiracy theory out of this. But I mean, this could be she's pregnant. This could be someone in her family is severely ill. This could be any one of a number of different things that has a finite amount of time that it will affect her. So you can imagine your mom has 6 months to live. You're going to ask to stay on the planet. We don't know what it is. We should respect her privacy while being deeply curious at the same time.
Well, that's the thing, right? Anybody who is at the press part of NASA would go, we're going to have to explain this.
Yeah.
And because people are going to, because, she's African-American, first female African-American astronaut to go to the International Space Station. Like, this is kind of controversial. And so they would need to explain it in a way that seems totally natural and is understandable. And all those reasons that you mentioned sound totally understandable. The fact that NASA didn't say it, that they're not specifying what the reasons are, is just going to open up everybody to speculation. And I'm not going to speculate, but I would think you would expect that NASA would get in front of this, or that she would get in front of this, that as soon as possible. And this is I think this is whatever's going on, it has already been handled badly, and it is already blowing up in NASA's face.
So honestly, if it's something like there's somebody in her family who's terminally ill, her whole family might be asking for privacy, and this is the only way they know how to handle it. And 6 months from now, they'll come forward and say, thank you for respecting my privacy. My mother was dying. You can think of all these sorts of different situations where the family would be like, we don't want anyone to know anything. So, yeah.
Okay. Yeah. Someone asked a question that I don't understand. A meme that I don't understand. Anyway, let's go. Any other questions? We've got about another. Actually, we're pretty much done.
Yeah.
So why don't we wrap this up?
So we will have our Patreon office hours starting in about 15 minutes. So if you are a patron of sufficient level, and I don't remember what that is right now, stay tuned. It's the same link as always. And Susie sent you notes earlier today. I'm making up for not being around last week. So we will also have office hours on Sunday. And so remember, you can support the show through Patreon. You can support it through PayPal. And I'm going to be working to try and figure out how to make sure that the people donating through PayPal get the same benefits as people donating through Patreon, because we're starting to understand why people make the decisions they make.
Yes.
Thank
Yes,
you,
I
all of
think-
you who are out there, though.
Yes.
And the stuff below us, that's our weekly Space Hangout crew. These are the people who are our crew, basically. They're our squad that gives us
Yeah.
input, keeps us going, supports us, does beta testing, all that sort of stuff. We could not accomplish much of what we do without them. If you want to get involved, go to wshcrew.space.
Right on. See you next week.
And
I'm just
now
going to sit here and wait for you to press buttons.
I have to find the button. Stop streaming.